Okay. Um, where were we? I think. Oh, my tiny little, pretty little finger. Okay. What am I supposed to do? Design a hash shirt. Fucking hell. How the fuck am I supposed to do that? What even is that? Like, what the fuck? Let's do some two pointer. Reverse a string. This should be easy, I think. I should not return anything. I should just reverse this string with no extra memory. So I think we'll do left and a right pointer equal to 0 and length of string minus 1. Okay, while L is less than or equal to R, we're gonna basically iterate over this loop, over this entire. So we're gonna start from here and here, and we're gonna swap them. So this will get swapped by this one, and it moves, gets swapped, and that's it. And there's two cases. One being when the length of the string is even, so divided floor division by 2. You're gonna do an inline. The inline is the least fun in all of this, so it's just simply S of L. We're just switching it, and when it gets to the middle part of it, it just switches one more time, and both are in the middle, and nothing really happens. So we're gonna switch equal to. I wanna go here, here. I wanna do that, and we need to increment this by 1, reduce this by 1, and we need to return s as a string. I don't have to return anything.
There's actually a slightly clever way to do this with another data structure. Now, it's probably less intuitive to come up with this, and it's also less efficient because we're going to need a stack. So that's
I'm looking at the stack solution.
Automatically going to be big of n memory complexity because we're going to potentially add all of these characters to the stack. But the algorithm itself is actually very simple. We're just going to go character by character, adding each character to the top of the stack. So first we add the H, then we add
we can do a stack.
then we add the L, the second L, and then we add the last character, the O. And then, a stack data structure, to remove elements, you can only remove from the top. But notice what we kind of did. We already reversed the string. The only problem is it's on the stack, and we actually want it to be in the string. So we're going to pop from the top of the stack the O, and doing that, get the phase of the algorithm. Start at the beginning of, go through every single character that we pushed to our stack, and then pop from the top of the stack and take that value and then assign it to the beginning of the string at index I. And then we're just going to keep repeating this until the stack is empty. But don't forget to increment your I pointer. So as you can see on the left, yes, it works, and it's also very efficient, but it does take extra space. So it's good to understand kind of the trade-offs and be able to because we're using space from the recursive call stack. And the last thing to do is don't forget to add an example how we're going to solve. To do is though an even number of characters, we would swap these two, then we would swap these
That's
two.
what I was trying to do.
Pointer be place. There's a version where the strings we're not really defining variable execute doing because we're just supposed
I know, I'm so awesome. Thank you.
these two, then we would swap these two solutions. And to be honest, if
Valid palindrome 2. Okay, let's take a look. So you're given a string S, return true if S can be palindrome after deleting one character from it. Okay. Yeah, I think that we can do it. So I need to go. I need to do a normal two-pointer where normal two-pointer approach. Right. While this is the important bit, I think. I might have to like come back and change the while loop, but I think when the characters meet at the middle or wherever they meet, it doesn't like give me like a bigger test case. let's say they meet in the middle and the left pointer passes through the right pointer, I think that'll be a good time to stop. So the main rule, or like the main edge case, would be to get like an if statement in the middle and to check whether, so whenever, so if this condition is satisfied, so S of L is equal to S of R, right? We can just continue when it's not equal. Let's go not equal for now. When they're not equal, you just go, okay, they're not equal. Let's look at this one. They're not equal. So let's try deleting this variable or this, right? So we're using an OR statement. So if S minus equal to SR or SL equal to R1, whatever, right? If both of them are equal, either we delete this one and check whether it's okay. No. We add. We don't actually delete it. We move forward with the pointer and see if these two are equal. If so, you can continue the thing to check if it's a palindrome. If that's the case, pass. Else, here we're gonna return false. So out of the loop, it's gonna return true. Let's see how it goes. Oh yeah, it's a double whammy. So yeah, this should be, yep. Okay. I'm sorry. If it is true, we're just gonna increment and decrement this thing, and yeah, let's submit. Compare these two. These two are not equal, so just, or these two are equal, so increment. These two are not equal, so we're gonna check, does these two are equal? No. Or these two are equal? Okay, yes. And there should be a while loop inside it, right? Okay, the same code. If it passes through the entire thing, it must be true. Yes. Yeah, whichever the test case, that is true. Bro, this is like the exact code that I wrote. The exact code, but I think I messed up with the true false thing. If I like go back and I think I can go back and fix it. So if you look at this one, this is the same code, right? Same as this one. So if string of this, what I wrote is, okay, let's check. Or this, I wrote pass, I don't know why. Just retardation. If one of these things were true, that means it's a palindrome. So I could just pass on to the next thing. Does it like execute L? It's probably not. So I can pass off. Ah, it's in the else block. That's why. I thought these were gonna get executed right after. So these should be. Let me actually like do this though. I think I can fix it. I think these should be in here. Bro, this is some fucking goofy ass indentation shit. Telling you. So these are equal. So just increment. Both are not equal. Checking. Checking if those are equal. No. Should I do a else if both are equal? I mean, else if both are equal, this gets executed. I think that's a bit cleaner, I think. Why? Like, there's no reason to go into the false ever, because this is true. This gets implemented. Just write the extra. Else. Okay, fine. It's true now. Why? So CB is checking CB is equal. Okay, it happened twice. Yeah, it happens twice. So the goal is to not let it happen twice. On my code, I think I can you can like do it like twice. That's the issue with my code and this code. Lot of memory though. Fucking retarded ass way to do it.
Okay, welcome back to AlgoJS. Today's question is leak code 680 of valid palindrome 2. So given a string, return true if the string can be a palindrome after deleting at most one character from it.
Bro, why are you looking like that, man? There's no need for you to look like that. There's actually zero need for that.
How's it going, guys? Today we're going to be going over another leak code question. Today our question is from Facebook and it's called valid palindrome.
Nigga, you don't need this intro, I'm telling you. You don't need this intro, bro. It's not that deep.
From the description, we're given this in the maximum B and C.
And you're teaching it in Java, you're like a faggot.
Okay, welcome back to AlgoJS. Today's question is leak code 680 of valid palindrome 2. So given a string, return true.
Hello. And then obviously the where the two palindrome. If not, we were not able. Reason that it's of our string minus. So index, which is where we're at on the right side, or if removing the right side character. So we're going to pass in the string, and this time we're going to say j minus 1 because we want to chop it at whatever we're pointing at the right, but one index before that, which is going to be j minus 1, to chop off that right character. If either of those is a valid palindrome, then we can simply return true here because we know that we can remove at most one character, and we're done. And then in our valid palindrome check, we're just going to check for a standard palindrome. We don't have to worry about any sort of like removing characters or anything like that. So that's the case when they don't match. If they do match, then we know that we can move forward in our string for the I pointer, and we can move down the j pointer. And at the end, if we get through the entire string,
Bro, these guys are idiots, man. Fucking idiots. Fucking idiots, mate. So, what was this solution? It's all like retarded, like, what is this? Not a good solution. So, yeah, we're using two. Want to check if it's okay, bro. Okay, little bro. Okay, little bro. I think the issue with this one is this should be outside. So let's copy this. Let's delete this. Go here. This can be outside of here. Self-taught, whatever. This is how actual codes are written anyway. Okay, I'll learn a little bit of this later.
True. Why? Because we could delete the character.
Oh, I've never done this, that's why. I've never actually done this. Oh my god. That's why. Makes sense.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem valid palindrome 2. We're given a string s and we want to return if it can be a palindrome if we delete at most one character. That doesn't mean we have to delete a character, but we inward this and then we start with the rest of it. Left pointer is going to be at the beginning one. So is turning false. So that's the main idea.
680. How am I even supposed to use a two pointer on this shit? It makes no sense. So let's take a big example. Okay, I'm taking two pointer. I think the two pointer should start at the same thing. Okay, start from bro. It's enough. What's the time complexity? Yeah, using the join. I think I've done this before.
Hey everyone.
Yeah, I've done this before.